Hello, everyone. How are you doing? It's a real honor to be here today. Thank you, ACM. Thank you, Bill, for giving me this opportunity. I see quite a few familiar faces in the crowd. I was a consultant here at PayPal, the other campus in the North First, where we stood up one of the early Hadoop clusters, I think almost 2.5 years ago. So a real honor and privilege to be back here again, speaking at an ACM event, no less. I also worked at Intuit, and I see some colleagues from Intuit as well in the big data group. So thanks and welcome all. It is definitely a talk on technology, but I've tried to kind of hit sort of a middle ground where it's not way too technical. But we can always dive into some of the technology pieces as and when we come across them. So before we dive in, I just wanted to kind of get a good sense of what people think about data pipelining, especially in the big data context. So any volunteers for what do you think is a data pipeline? Simple, non-technical definition. Anybody?
Data flow through a bunch of programs on a bunch of computer systems.
Excellent, excellent. So it's sort of the intuitive definition, right? I mean, we are familiar with pipelines and, standard Unix command line pipelines. Take the standard out from one program, give it into the standard in, and so on. It's roughly the same concept. It's fundamentally oriented around data flow and how data flows through a complex system. Now, there are so many hidden issues here, and this is obviously a very hot topic. Just do a search on LinkedIn for the number of pipeline engineers that they're looking for. LinkedIn itself is hiring heavily, and so are several other companies in this space. So obviously, it's a huge need and a very, very relevant topic right now in the big data space. So what I like to do is not just talk about the technologies and the tools and frameworks, which we certainly will be, especially towards the latter half of the talk. But I also wanted to kind of talk about all of the unaddressed issues in data pipelining for big data. I mean, there's a whole host of issues that you barely ever hear about. And those are the real hard problems, actually, in pipeline engineering. So setting up the data flow, fortunately now we have mature frameworks and pretty mature tools that it's not as hard as it used to be, say, 3 years ago. But addressing everything else, that's the challenge. And that's where there's a lot of innovation going on as well. So let's dive into that.
So at a high level, what is the problem that data pipeline solves?
Effectively, it's about managing data and data flows into and out of a big data system, right? I would say that's sort of like the intuitive definition of what a pipeline is. But that's not where the problems are. That's not the complexity. The real problems are in these areas. And this is where building a scalable and flexible data pipeline for big data becomes a very, very challenging project. Okay? So if it's just a matter of, hey, get data from here, pipe it through here, store it there, write some sort of an index, put some metadata, and you're done. That's typically what you see in most books and tutorials, et cetera, when they advertise, oh, we let you build a data pipeline. Well, how do you deal with legacy? Okay, how do you deal with security, privacy, data lineage, and we will dive into what this means. Data provenance. How about data lifecycle management? These are the real complex topics in data pipeline engineering, and these are the ones that are not spoken about. Those are not addressed, and that is what I would like to talk to today. Okay, there was a question.
Yeah, so I was just curious about the difference between data pipelining and ETL.
The difference between data pipelining and ETL. I would say there's a strong overlap between the two terms. I would say, this is again my subjective point of view, ETL is a subset of what is data pipelining. And I would say ETL is perhaps better used in the relational world. And it's still widely used, and there's no harm. In fact, I have a section on that actually as to why ETL is very different in the big data world. So we could talk more about it then. Okay. So let's dive in. Okay. I just wanted to kind of set a little bit of historical context of what we are talking about, and especially when we talk about legacy. Okay, I'm sure everybody's seen what Hadoop is, the 3 V's, etc. Right? What I don't know if you're aware of is Hadoop 2.0, which is a complete overhaul, I would say, of Hadoop. So Hadoop 1.0 was a data processing system. What they've done with Hadoop 2.0, they've turned it into a distributed computing platform. And the data processing, or what is called MapReduce, is just one application that runs on Hadoop. And the underlying fabric, if you would, the underlying platform is called Yarn, which stands for Yet Another Resource Negotiator. It's a horrible name, I know, but it's but you can think of Yarn as sort of like the modern data operating system, right? You can run any kind of application on top of Yarn. And the old MapReduce, which was this batch data processing capability that Hadoop 1.0 gave, is just one application on Yarn. And people have started building all kinds of new applications on Yarn. So it's really, really exciting times with Hadoop. It's evolved into like this I would say almost a supercomputing platform. And it's obvious that I really love Hadoop, right? The other common misconception about big data is that everybody thinks big data is just Hadoop. And I don't know how many of you had a chance to go to the Strata conference, you would have seen so much more activity beyond just Hadoop. In fact, last year, 2013, O'Reilly, which organizes the Strata conference, they had this big banner that says, not only Hadoop. And we'll see why it's not only Hadoop, right? There's newer systems, stream processing frameworks, in-memory analytics frameworks, graph databases, etc. All of that are now coming into the big data landscape, right? So keep that in mind when you hear big data. It's not just Hadoop. Although Hadoop, I would say, it's at the core of it, especially with Hadoop 2.0 and Yarn. But it's grown beyond, much beyond just Hadoop, right? Now this poses some very, very unique challenges to the data pipeline engineer. Okay? To the question on ETL, if you think about the relational database world, you kind of had a standard, ANSI SQL. Okay, granted, it took a while to standardize SQL, but eventually you had a standard. And you had a standard set of tools, right, built to that standard query language. And effectively, you started programming, doing ETL in those standard set of tools. Now, what you see here is an entire ecosystem. It's like, it's not even herding cats. It's herding the entire zoo, okay? It's lions and tigers and zebras and giraffes. And you're supposed to manage all of this and build a data pipeline that spans across all of these very, very diverse systems, right? That complexity in and of itself is very, very challenging. And we'll talk about that. And last, I really want to emphasize this point. In fact, I have an entire section on legacy data. I do a lot of consulting work with banks, and I frequently work in the East Coast. If you leave Silicon Valley and go outside, you will have no choice but to deal with legacy data, right? Not all companies are startups with a year or 2 years of data. Not all of them are just dealing with advertising technology or doing log analysis, right? You have healthcare data, you have financial data, highly regulated, you have privacy issues, compliance issues. So dealing with legacy is in fact a very complex problem, and again, it falls in the domain of data pipeline engineering. So these are all the things that people don't typically talk about when they talk about data pipeline, right? So I kind of have this summary slide as to why is it so hard, right? And this is what all of the Hadoop vendors sell. I got nothing against them. I think it's a phenomenal vision. Okay? They're saying, I think the term for now is like enterprise data hub or data lake or something like that. It's basically, all these different rivers and streams of data just fall into this big ocean called big data, and everybody coexists, and there is nirvana somewhere in there in terms of predictive analytics. It's a very compelling vision, except when you start actually implementing it. Okay? Okay? And this is why it's so hard. Okay? It's just not that simple, right? There's way, way, way too much complexity in real-life systems. There are privacy and compliance issues. Spoke about that. ETL is definitely non-trivial in the big data world. Building a reliable ingest mechanism against, again, you're herding an entire zoo, is not easy. Okay? And data lifecycle management, I mean, if you look at the relational world, there are very, very mature tools to do data lifecycle management. It's just not there in the big data world. And it becomes very critical when you're dealing with very, very large volumes of data. Do you want to keep petabytes and petabytes to replicate it 3 times in your Hadoop cluster forever? What is your strategy to migrate data in and out? What's your strategy to sunset the data? Well, the vendors don't really talk about it. And if you are left with the task of building and maintaining a data pipeline, guess whose job it is? It's yours. Okay? So these are the issues that you should be aware of, especially if you're either looking to enter the field of data pipelining for big data, or you're already doing it, right? I'm sure some of you are already dealing with this if you're working this space. So I briefly spoke about it, right? Outside of Silicon Valley. All right, how many of you have worked with mainframes? Oh, good, yeah, good many, okay. I never have, until recently. I started consulting with a whole lot of banks. And I was in a meeting, and I'm like, oh, you can do this, and you can use Scoop to bring data in, and I was kind of giving my usual spiel about the wonders of Hadoop. And somebody asked me a question: how do I import copybooks? I said, what is that? So if it's XML, we can handle it. there was this huge kind of this vacant silence, and I know that's an oh moment. I'm like, oh my God, what did I say? Apparently, it's COBOL copybooks. I learned a lot about copybooks in the next 2 months. I didn't know what a copybook was. In my career, I have never worked in COBOL or mainframes or DB2 or CICS or any of those systems. I've heard those acronyms. That's about all. So it's a very, very practical problem. Lots of banks, financial institutions, the government, healthcare institutions, they have a lot of their critical data in mainframes. There is no reliable ingest mechanism to import mainframe data into Hadoop. There's no open source that I'm aware of. I looked and looked. So the only solution is a commercial solution by a very enterprising company called SyncSort, which was quick to seize on this opportunity. They are a traditional ETL vendor. And they realized, oh my God, okay, people are going to want to put their mainframe data into Hadoop. Well, we should build a tool for that. And they're making a killing. There's nobody else. So after looking and looking and looking, and I'm sort of an open source fanatic, I finally gave up. So that really, really taught me, okay? Think about that for a second, okay? Something so obvious. I was completely blindsided by it. Most of the work that I did in the Valley involved log data, ad tech data, okay, some XML data, geolocation data. Who deals with mainframes out here? Okay, I never had an opportunity to do so until I was required to do so. So dealing with legacy is very important. And I really wanted to talk about my experience with mainframes, but there's a good possibility that somewhere in your career, especially if you're dealing with big data, you've got to deal with mainframes. And as I found out, as I learned a lot more about mainframe systems, the way the old COBOL systems handle and represent data is not that different from how Hadoop looks at it. The data and the schema are very well separated. The copybooks tend to be more on the schema side. So it actually maps very nicely to Hadoop. And that was a revelation to me. So knowing the legacy and dealing with legacy is perhaps the first thing you got to do when you're in a data pipeline environment, right? If you ever put on a project in a company that's not, been around for 3 years and got acquired for $19 billion, there's probably lots of data. And knowing how to deal with that legacy data is going to be crucial for the success of the project, right? There's a whole bunch of issues when dealing with legacy data, and trust me, beyond the textbook examples of, hey, connect this to this to this to this, and voila, put it in Hadoop, and you're done. These are all the problems you're going to be faced with. How do you deal with it? Okay, so you better have good approaches to dealing with missing data, missing schema, invalid data, inconsistent data, okay, and above all, sparse data, which becomes very important in data science. Yes.
So it sounds like that would have to have reporting on exceptions and then going and talking to people to figure it out. If you had some schema problems, for example, fuzzy data.
Absolutely. So the question was, the approach would be to raise exceptions and then flag them and go talk to someone. That's definitely a good approach. In fact, what I would recommend is make sure you have this exploratory phase in your data pipelining project, that you actually literally make it a point to go understand all of the legacy data and how it is currently used. What are people doing with it? What reports are being generated? What ETL jobs are running on it? Before you go and start doing any work with Hadoop or anything else in the big data system, right? So that exploration is I think it's time very well spent, and it's often ignored, because you can very easily just go off into la la land and start doing your wonderful Hadoop work, and then you realize, oops, this doesn't map, and you're in a world of pain after that. So it's time well spent. Yes.
So in the typical ETL, these things commonly occur in data cleansing stage. There's already solutions for this. How they different from what you're suggesting in Hadoop or big data environment?
Repeat the question.
Yes. So the question is, there's already solutions for data cleansing and data quality. So what am I suggesting that's different? Yes, there are lots of good commercial solutions. There aren't that many good open source solutions. I mean, there are a few. If you're using something like Pig, there's Datafoo, etc., to help you deal with some data quality issues. All of them are missing, in my opinion, all of them are missing a very critical aspect of data quality, which is data curation. Getting humans to actually look at what you're doing and getting feedback is essential. Until and unless you build a curation step into your pipeline, especially when you're dealing with legacy data, there's probably somebody in that organization who's worked with that for the last 30, 35 years. Getting that person's organizational tribal knowledge is very, very important. So that is really not covered in many of the commercial products even. But if you're in an open source shop, you're kind of tough out of luck. You have to roll out your own. There's a little bit of helper libraries, etc., but for the most part, you're on your own. Yes, another question.
Hadoop's MapReduce environment has a weaker consistency model, especially with the MapReduce environment. So when it comes to sensitive data, how do you address that particular pitfall for Hadoop or MapReduce in general?
Sure. I actually have a security and privacy section where we can talk more about it, but I can briefly address your point. The question is, given that Hadoop has sort of weak or eventual consistency, how do you deal with sensitive data? There isn't a single approach that will solve it. You've got to look at what pieces of your data set are sensitive, and you've got to figure out how to mask it. You've got to figure out how to protect the privacy, and perhaps if you need encryption, strong encryption, you've got to figure out how to do that. Again, there are several good commercial products in all of this. There's products like Gazang, for example, that'll do it. None really in the open source that are.
Actually, sorry.
I'm sorry?
There's something called invariance that you can invoke in Hadoop, as far as I can remember. But I'm not sure if you mess up something in the application there for the invariance, that might.
There really isn't anything in the core programming API that actually addresses data level security. It's something that you have to build in your application. There's things that for example, if you're writing to a Hive schema, you can define things a certain way, but in your logic, in your ETL logic, in your data pipeline logic, you've got to write application code that says, okay, this is social security number. I am not going to show the entire social security number until you authenticate yourself. And I'm only going to, if it's a credit card, I'm only going to show the last 4 digits. That level of logic is not automatically built in. You've got to do extra work to do that. Unless you use a commercial product, in which case you get that, but you're paying for it. Okay?
Just a quick one. I mean, I could have written that list in the 90s when I did data warehousing. What's different now?
There's nothing different. See, the funny thing is, the big data world kind of, it started off with log analysis and search indexing and a lot of text analytics, right, which it really excelled at. When it's become kind of more and more mainstream and they're dealing with more business data, transactional data, all of those traditional tools and principles that people have lived with forever become important, and they hadn't thought about it in the past because it wasn't that kind of data. It wasn't used for really transactional data, structured data analysis in the past. But now it's becoming very relevant because people are putting those kinds of data into Hadoop and using that for analytics. So now there's a huge need for dealing with these issues. And especially, so if you've done data warehousing, this is actually a pretty exciting time because, believe it or not, you're not obsolete. You're actually in very high demand because all those concepts that you learned way back are now very, very applicable because you're doing what you were doing before, except you're doing it in Hadoop. That makes sense. Good. All right. So ETL. I know somebody asked me ETL question. Okay. What's the problem with ETL? Well, first of all, the name itself. There's an inherent assumption in ETL that you're doing extract, transform, and load. Okay, in that order. And I like to think of it. I mean, there's, I got nothing against it, and I'm not into some sort of religious debate about terminology, but I really think that ETL was built at a time when the data sets were really small, and it made sense to perform the ETL process out of band, like outside your database, before you bring the data into your database, right? And that was one of the best practices, bring good data into your relational database. The assumption that the transformation will happen out of band, and what I mean by out of band is it's outside your actual data storage system, right? If you look at more traditional ETL systems, they tend to do it in memory, or they have their own complex framework to do the transforms. It's very compute intensive. It has a lot of math operations behind it. So they would do that, if you're used to things like Informatica, and then do a bulk load into the database, hence the name ETL, extract, transform, load. That doesn't work when you're dealing with hundreds of terabytes of data. Why? Because the out-of-band process of processing such large volumes of data outside of Hadoop is just not feasible. And the whole point of building Hadoop is to let you process large volumes of data. So the emerging paradigm for ETL is to flip the T&L, right? So in the olden days, you did the extract, you did the transform outside the database, and then you did a bulk load. Now you do the extract, you dump it into Hadoop. Then you leverage Hadoop. You leverage the parallel distributed processing capability of Hadoop to do the transformation in Hadoop, right? So the transform step is not out of band anymore, okay? Now this is a fantastic story, and in fact, way above any of the other use cases that people have for Hadoop. One of the reasons why Hadoop has grown as fast as it has is exactly because of this. I mean, all the data science and all the cool analytics, all of that really comes later. What people are really using Hadoop for is to get rid of their expensive Informatica and expensive Oracle systems, believe it or not. The ETL on very, very large data sets can be pretty expensive. So ELT is actually, I would say, one of the most important use cases for Hadoop. Now, what's the problem with this? Okay, before I do that, anybody see a huge problem in doing the load before the transform?
Transferring each time anybody wants to use the data. You have
Yes.
garbage in the data as well.
Yes, you have garbage in the data. So all those data quality issues we spoke about, right?
Sharing with you.
Yeah, so you're no longer putting good data into the system. You're putting junk data, questionable data, and every other kind of data into your database. And then you're saying, okay, I'll process it and get good data out of this. Okay? That poses some very unique problems. Okay? The first and foremost is security. All right? Hadoop security has come a long, long way, I would say, in the last year and a half. Okay? Prior to that, you pretty much had Linux file system security, and that's it. Okay? Now they've added Kerberos and active or LDAP integration and encryption and so on. It still doesn't go far enough. There's still a lot of people hesitant to put really sensitive data into Hadoop because of security issues. But let's talk about ELT. If I load sensitive data into my database that is not fully secure, and then do the transform, I've just opened up to a whole world of lawsuits, especially if I'm a bank or a healthcare facility. Okay? This is why one of the biggest challenges data pipelining is not just dealing with legacy data. I would say the second biggest challenge is dealing with security, because what everybody tells you, you go talk to any of the Hadoop vendors, they tell you, oh, just throw it in Hadoop and do the transformation there. What they don't tell you is how to deal with security. And guess who has to deal with it? You, the data pipeline engineer. Okay? So be very, very aware of this. There are, again, commercial solutions that allow you to do, I'm going to talk about in a second, what's called a secure extract. It's still not fully mature, and there's still a lot of work, especially if you're dealing with PCI, PII, or any kind of sensitive data, right? I really wouldn't still put HIPAA data anywhere in Hadoop until you've got truly HIPAA compliance baked in. But you really need to understand the security and privacy aspects of it as a data pipeline engineer. So, so what I'm trying to really say is, data pipelining, although the naive definition is, just input to output to input to output and write. In real terms, it's never that. That's not where the problems are. That's not where the challenge is. The challenge is all this stuff. Okay? So let's see how you can solve this problem. Okay? So you still got the E before the L. Right? You're still doing an extract. So the current approach, the current thinking is to do a secure extract. So deal with security when you're extracting the data. That is perhaps the easiest place to deal with it. It is also pretty complex. It makes your pipeline way, way, way more complex to build. Because now you're not just thinking about throttling and throughput and things like that when you're extracting data. You're also thinking about security. So even when you're extracting log data, a very simple example is Hadoop is very commonly used to extract log data, and very often a lot of older frameworks, when they log a failed login, they often put a password in clear text. Now, if you're the data pipeline engineer, okay, you better not put that password in clear text in Hadoop, okay? It's just a big no-no, okay? So you need to worry about things like that. So, you could naively go and just dump that data and write some sort of pig script and put it in the Hive, and you think you're done, until any analyst who has access to that data can now see all the failed passwords, okay? And pull a Snowden on you, okay? And you don't want that. You don't want your name associated with that in any way. Okay, so worry about security, yes?
So how would you attack that kind of problem or solve that kind of problem? Is there a solution that you've seen used for that?
Yes, there is quite a few good commercial solutions. Again, the big companies are all buying products that solve this, right? So they buy Hadoop, and then they buy all these different point solutions to solve these specific problems. There's companies, so the question is, how do you really do the secure extract? There's Gazang, there's Data Guys. There's quite a few companies that have products that address this. The real problem comes is when you're doing open source. So let's say you're building your own startup, and you're dealing with, I don't know, you're doing the next quantified self startup where you're recording people's heartbeats, every minute or something like that. That is very sensitive data, okay? And you can't afford to put a gazang or, not unless you have lots and lots of money, okay? What are you going to do? Well, you've got to roll out your own. And there will be some open source libraries coming up. And actually, part of my sort of selfish goal in doing this talk is to encourage more open source work in this. And I'm actually talking to a few people to kind of kick off a set of open source projects in this, and hopefully address some of these issues in the data pipelining frameworks. And I'm going to talk about it at the very end. But on the open source side, there really aren't good solutions for it. Everybody rolls out their own. The last thing you want as a startup is to fail a HIPAA audit or fail a PCI audit. I mean, that's pretty much the end of your company. So especially if those of you who are running startups and doing Hadoop work, be very aware of security and compliance. It's not nearly as mature as people would lead you to believe, right? I would say fret over it quite a bit, especially on your data pipeline. So the solution is, again, secure extract. There's other problems with secure extract. Again, here you're assuming that you really, really understand your data, right? If you have dealt with application logs for a long time, maybe somewhere a light bulb goes off in your head that says, oh, gee, this framework logs all failed login attempts with the password and clear text. What if you didn't know that, right? What if you didn't know which ones are exactly HIPAA controlled and which ones are not? Those of you, maybe you're dealing with financial data. FEFCE regulations are ridiculously hard to read and very, very hard to implement. How do you go about doing this, right? So secure extract really assumes that you understand your data set. And again, I would re-emphasize, spend that time up front, understand what data you're dealing with, and look at it from the security angle very, very hard. Because if you don't, then you're going to run into these kind of issues later on. So secure extract is a good approach, provided you've done the due diligence up front and have really understood your data set, right? So here's a very unique problem, okay? How many of you have done social media analytics? Maybe in the past? Okay. I don't know exactly when Facebook kind of introduced its change in privacy. I think it rolled it out I want to say about 2 years ago. But I remember I used to work at a startup in 2010, and it was wide open, okay? And that was a time where people were literally just rolling out these social apps, and people are a lot more conscious of privacy today. They weren't back then, because they were just getting to know all of the social media stuff. So they would just widely open and gladly give access to their Facebook profile to anybody who asks. And all of these people were data mining, okay? So once you get a Facebook token, I can keep listening to all the activity in your Facebook profile. Now, they have changed this, by the way. So I don't want to freak you out, okay? But especially right before they went IPO, they put in a lot of effort into this. But way back then, it was the Wild West. So let's say you're a company and you've been around for, let's say you're one of those digital marketing companies, right? There's tons of those. And you have, 500,000 Facebook profiles from 2009, when the privacy policy was very different than what it is today, okay? And you start doing all these fancy social media analytics, customer segmentation, and you're aggregating the data and you're selling it to marketers, okay? And somebody gets really irate and decides to sue you. What do you do? Right? You could argue that, hey, at that time, the privacy policy states, and you gave me access to your Facebook profile, I had the token, so you can't really sue me. I mean, you let me have it, right? And the user says, well, I didn't know what I was getting into, right? And a lot of times, if you get into court, the user would probably win, right? So there's one way. Yes, please.
Isn't the real risk here, though, if you're a data broker like that your downstream clients with the deep pockets are the ones who will get sued?
Usually on a lot of these suits, they name everybody.
Yeah, so
it's one of those.
You're a very prominent retailer that buys data from data brokers.
Yeah.
For marketing purposes. And all of a sudden you discover that you've got sensitive information in an otherwise, innocent data stream. What do you do?
Yeah, they actually kind of do hedge themselves, and they have terms of agreement this long, and an army of lawyers. And usually what the other thing, well, actually, a lot of the good data brokers will anonymize the data. They won't sell individual data. And the companies that consume the data would buy it from multiple brokers and mash them together so that it becomes even more anonymized. But it still opens room. I mean, and the real issue here, in fact, this was pointed out by a lawyer friend of mine, and she said, look, nobody's done this yet, but I'm waiting for a lawsuit in this space around privacy policy, right? There's a whole bunch of consumer rights that are violated. When you give out access to your private data, although you give out consent, it's not considered informed consent, because you don't know what you're doing, right, at that point. So how do you protect yourself?
One question.
Yeah.
When you put the security at the extract level, don't you end up filtering the data? Unless you are selling the data to some third party, the very purpose of Hadoop just to archive whatever raw data you get. That purpose is not lost there.
You should not actually give access to that raw data. That's the whole point of compliance. So, for instance, if you have social security numbers in that data, you better have all kinds of audit and security controls before you put it in Hadoop. And Hadoop doesn't have those yet. There really isn't a good data governance solution within Hadoop yet. So if you do put it in Hadoop, then you're in a world of trouble if you ever get audited, right? If somebody comes in and asks you for a PII audit, you will fail that audit. So the current recommendation is don't put it. And if you're going to put it, mask it, scrub it, anonymize it, and then put it, right? Until we have a good data governance solution that works at the HDFS level, right? A lot of the other databases, if you look at Oracle, it's no problem, because they have very, very mature support for these things, right? Hadoop does not. It's coming. It's coming. It's just not there yet. Okay, so getting back to our Facebook problem, how do you protect yourself? Okay, this brings to a very, very important topic of data lineage and data provenance. Okay, this still doesn't truly protect you if you're doing data mining. But this is definitely a step in the right direction. Even if you're a startup, you should definitely worry about this, because if you're dealing with human data especially, you better worry about this. Okay. So what is data lineage? Data lineage, basically, it's actually very simple. Data lineage records the origin of data. Where did your data set come from? And data provenance records all of the change history. So every single change, every single transformation that happened to your data since its origin in your system, right? And these two usually go hand in hand. And they're very, very important of what's called data management or data governance. And there's very, very, very mature tools to do this with relational databases, and pretty much no tools in Hadoop to do this. And again, there are commercial solutions, but if you're an open source shop or you want to keep it open source, there are no solutions. So you got to be aware of this, and you got to build your own. Okay, so let's go back to the Facebook problem. Okay, one approach. Again, this is by no means foolproof, and you better put all kinds of conditions around this. But record the lineage information in some sort of metadata registry. Okay, and you might have to roll out your own on top of Hadoop. Okay, or you could use things like the Hive metadata or HCatalog to do this. Okay. What this really does is it protects you as a consumer of the data set. Now, if you ever get audited, if you ever called into a lawsuit, you can say, look, I got this data with this explicit consent from this user at that time, and I am protecting this data in this way, and these are all the change histories that happened to it. And I guarantee you, I did not violate my terms of use with this user. Right? They gave me consent. Whether or not it was informed consent, whether or not they actually read the use policy is their problem, not mine. Okay? So this level of tracking and auditability is very, very important. And you have to roll out your own. Yes?
But once you say a data is sensitive, and you also have the data lineage, in spite of any amount of anonymizing, people can always go back and find out the real data.
Not if you do a secure extract. So this goes back. So let me repeat the question. Is if I understood you correctly, you're saying once you have data lineage, and if you have data lineage, I can, no matter what amount of security I put in, I can always go back and look at the original data. Correct?
If you anonymize, what I'm trying to say is that how are you going to protect yourself from lawsuit when somebody can track back the actual source and actual data? Because in spite of your anonymizing, you're not really losing the, you're not really anonymous. The data is not anymore anonymous.
The anonymity, so the data is not really anonymous if you have track back features through data lineage. So data anonymity is how you store the data and how you consume it. So let's say I buy your data from somebody who data mined you and sold me all of your web logging history, okay? And believe it or not, this stuff actually happens, okay? That person is most likely, if most data vendors are not just going to give out that data, right? There's terms of use, and I won't know your exact email ID. That person might know it, but I won't know it when I buy that data. So I only know that, I know demographic aspects of you, I might know locations, etc., but I won't know direct personally identifiable information, right? That's a violation. Despite that, although it is still anonymized data, I might still be named in a lawsuit because I purchased the data from that vendor who data mined you. So how do I protect myself, really? I should still do data lineage to say, this is the term of use that I had with this vendor, and I'm released from liability, okay? And I anonymized it, this data was anonymized, and I put it here, and this is all the change history that I did, right? It gives you some level, again, it's not foolproof, it gives you some level of provability, which is what provenance is, which is somewhat legally acceptable, right? And you might think, hey, this is for big banks, etc. Anytime you're dealing human data, you got to worry about it. Even if you're a small startup, you got to worry about this, okay? Right? Okay. So here's an astute yes.
So even though I agree completely that the data lineage and data provenance is important, but even if you assign that to an input data set that has lots of different individual records in it, as soon as you then burst that out and distribute it through the system, you still have to keep track potentially of the provenance, the lineage within the system itself in order to do that, would you not?
Yes, yeah. So data provenance, especially in a big data environment, is a very complex problem, and data lineage too. Usually, if the number of transformations that happen with data sets in a big data environment are way, way, way more than what happens in relation databases. Because of this approach that, hey, we will just dump and use Hadoop as cold storage. And then tomorrow, we will extract certain bits, put it into Hive, do some analysis. Day after tomorrow, we'll extract other bits, put it into another Hive schema, do analysis. So the issue becomes very, very complex. So there's only one commercial product out there by a company called Revelytics that has actually solved this. And they're making a killing selling their product. That tells you how hard a problem it is. And those guys were smart enough to anticipate this a year and a half or 2 years ago and kind of went ahead of the curve and built a solution. Yeah, it's not an easy. So I'm going to highlight a couple of approaches that allows you to think about building the system if you were to build this on your own. But it's if you are a large company and if you're dealing with data pipelines and sensitive data, I would advise you go buy commercial products. If you happen to be more of the startups, then again, my passion is really around open source and startups. You kind of unfortunately have to roll out your own, in which case you have to start by extracting all the metadata that you possibly can from your data set. Okay? This is actually a learning problem in and of itself. Okay, it's not just, a lot of the naive metadata systems tend to just do regular expression matching. Okay, that won't just cut it. There's a lot more you got to do, a lot more work you got to put in. Again, understand your data set. Remember the exploratory phase, and start building a solid metadata registry. And I would actually recommend, if you're rolling this out, use one of the newer NoSQL stores that allow you some sort of flexible schema. MongoDB would be an excellent choice. Put it in JSON, throw it in there, and you can always annotate it later on, and it tends to work really well rather than like a fixed relational schema. You can start off doing rule-based, but you really need to kind of do a little bit more of learning systems. And again, this is why data pipelining is not as easy as people think it is, right? I mean, we've already touched upon security, compliance, dealing with legacy, mainframe data, and now we're talking about doing some sort of automated learning for metadata extraction, right? So in a way, if you are a pipeline engineer working on big data, you're kind of becoming a jack of all arts, and that's what's required. Okay. So this is why you need provenance, right? So you've got Lineage, which tells you where your data came from. You need provenance to track what's happening with your data, right? Now, data provenance, you could teach a 3-credit-hour course just on data provenance. That's how complex the topic is. And obviously, I'm not going to spend that much time. There's two broad approaches. One broad approach is what's called workflow-based, which is very easy and kind of intuitive. As your data is flowing through, in your workflow, annotate all the changes, right? When you're doing the transformations, keep track of those transformations. Put it in a registry. Hey, you already built a metadata registry, right, in the previous step. Well, keep annotating to that registry. Okay, so that's very, very intuitive, and anybody who's building a data pipeline ought to do this. I mean, this is mandatory. It's not optional, in my opinion. The second approach is what's called the data flow approach, and this is actually what most commercial tools in the relational database world do. And that approach is pretty complex. And it gets very, very complex when you're dealing with large data sets. This is very automated. For instance, I could have data flow-based provenance in Oracle where for a very sensitive table or even a sensitive column, anybody who runs a query on that column. So if I say, select star from this, but I'm doing select SSN or select birth date even, it'll automatically record it. There's that level of provenance built into relational systems like Oracle. That just doesn't exist. You can't do this with Hive. Okay? You can't even write a UDF to do this with Hive, really. You've got to go and change the underlying bits of Hive to even start doing this. So doing data flow-based provenance, if you really want to do it, yeah, you can go mess with the underlying infrastructure. I wouldn't recommend it. Let others solve that problem. But at least start off with the workflow-based provenance. Okay? That is actually very easy to implement. As you're building your workflow, make sure you record each and every transformation to the best you can. Okay? Yeah, there's really nothing to help with you. So, sorry, I keep saying there's really nothing to help with you. So it's not me trying to discourage you. It's actually to encourage people. And those of you who are coders, programmers, and if you're running startups, please contribute to the open source community. We will all love you. Lots of good stuff has come around this way. So as you're solving some of these problems, put it out in an Apache 2 license, and we would all thank you quite a bit. These are hard problems, and I'm sure we can evolve a set of best practices around this. That'll help everybody. Okay. I'm going to talk really fast about data lifecycle management. I know it's kind of getting late, so I'm going to zip through some of these slides. I think data lifecycle management kind of is self-explanatory. It's pretty much from origin to sunset, right? In data systems, again, it might have gone through several steps before it, so it's typically defined as from ingest to sunset, right? From the time you are aware of the data, right? That's why your data lineage starts, all the way to when you move the data out. Now, why is this important? Okay. In a big data world, you're moving large pieces of data around to solve the lifecycle problem, right? If I'm generating several petabytes of data a year, okay? If you're a wildly successful startup, that's possible, right? Again, I'll go back to my favorite quantified self example. If you're running some sort of a quantified self startup and you've got tracking every single life metric of individuals and you've got millions of users, yeah, you might be generating that much amount of data. You probably don't want to keep all of it all the time in Hadoop. Okay, there's cheaper, slower cold storage even beyond Hadoop. Now, the Hadoop vendors will never tell you this, because obviously they want you to spending more money with Hadoop. But there's no reason to keep this data around in Hadoop beyond its usable lifetime. So you're better off putting it off to really dead storage and then bringing it back whenever you need it, right? That involves moving large amounts of data around. That's a data pipeline problem, okay? And trust me, any mature production system where you're building a data pipeline, you will be doing this. The capacity is not just going to grow infinitely. At some point, you're going to age data. So you better have a strategy to do this. Again, not much. Again, there's excellent commercial tools, nothing in the open source system. Now, this one's actually not that hard to build. This is fairly easy, and you should really build this into your pipeline, right? So put some sort of an expiry time on your data. Okay, don't just if you don't do it when you're doing a data pipeline, then you have no way to know when to actually expire your data. So, yes. Question?
Once again, if you're taking record-oriented or row-oriented data sets, and you're now going to burst that into column-oriented and distribute it across multiple platforms, you have yet another issue with lifecycle management, because now the data is spread out across the entire system.
Yes, so a very good question. So the question is, okay, I've got record-oriented data. That's typically how I get my data. Think log files with some sort of timestamp and a bunch of fields. I'm going to extract specific columns and put it into some sort of columnar stores. Fortunately, most of the columnar stores actually come with a timestamp built in. Most of them, in fact, look at HBase or even Cassandra, they have this notion of data expiry, which few people use. So you could still do it, but you have to do that extra work, because otherwise it just sets it to some default ridiculously large value that is meaningless. But if you know that this particular data set is not going to be useful after 2 years, and if you are doing that transformation where you're going to take certain columns of it and put it into a different columnar store, use the features of the columnar store and age that data.
Yes, but you still have to also write the history of the lineage metadata with it, so you know where it came from.
Yes, absolutely. Yeah. So when you're, that's another interesting problem. So if again we spoke so much about lineage, what do I do with the lineage data and the provenance data when I age my data, right? If I'm expiring my data, well, don't throw that away, okay? And usually that tends to be really small, right? You're not going to have terabytes and terabytes of lineage data for petabytes and petabytes of data, right? It tends to be really small. So that is very, very valuable metadata that you never want to throw away. So take your raw data, age it. Don't ever throw away your metadata, okay? There's lots of value in that. So, and it is not an easy problem. The actual data lifecycle management, I think, is fairly easy, and you should do it. Put a expiry date on your data set, but be cognizant of all the other issues surrounding data lineage, etc. Okay. All right, so let's talk about. So again, we spoke that big data is not just Hadoop. Now you've got all these different things, right? You've got queuing systems like Kafka, stream processing systems like Storm, real-time in-memory analytical systems like Spark. You've got NoSQL systems, HBase, Accumulo, what have you, right? And then you still have MPP systems, right? And most production houses, especially in large companies, they do use some sort of an MPP solution along with Hadoop, along with the relational database, along with NoSQL. Okay. So
what is MPP?
Massive parallel processing. So things like Teradata, Exalytics, Oracle Exalytics, Exadata, etc. Right.
And what is the difference between stream processing and real-time systems?
So stream processing typically tends to be like CEP-like systems, right, where complex event processing, where there's just large amounts of events just flowing through, and you're just looking for very simple patterns. It doesn't have large amounts of state, right? Yeah, so you're looking for very, very basic patterns. It's not designed to solve, let's say you can't do real-time learning on these systems. The real-time systems like Spark, you can. It's built to handle considerably larger amounts of state than stream processing systems. Right? But they're both in memory for speed.
And where systems like Kafka are used, queuing systems?
Queuing systems like Kafka, they're used all over the place. It's used for reliable kind of buffering of events before it's played into Hadoop.
Do you usually see Kafka paired with Zookeeper?
The standard install is with Zookeeper, with the Zookeeper quorum. So Kafka Storm uses Zookeeper as well. Each of them actually run their own Zookeeper core. Yeah. So a modern data architecture, and I think this is a term from one of the Hadoop vendors, so I decided to use that term. It basically means, again, you're not hurting just cows, you're hurting the entire zoo. Okay? You have to worry about data flowing through all of these systems when you're building your data pipeline. Now you understand why this is such a challenging job, right? I would say a good data pipeline is essential to good data science. You know, without all of this hard work that you put into the data pipeline, you're just not going to enable your data scientists with good quality data for them to generate good models. So you've start to think, and this is another one of those key takeaways when you're doing this. Start treating data as an asset. Okay. This is again a very well-known practice in data warehousing in relation databases. Right. It's not as well known in the big data world. So just look up data as an asset and asset management. Okay. You know, there's a whole lot of metadata that's associated with data that you really have to worry about when you're dealing with data pipeline. And one of them is all of these notions of how is this data going to be used, and that becomes your asset tracking, right? And this allows you to set up nice schedules. So let's say your CFO is going to look at a very important report first thing Monday morning. You want to set up your pipeline so that this runs reliably Friday night, and maybe it takes let's say 10 hours to run, and it runs across this Flume that does the collection, and then it goes through Kafka, and from Kafka there is a real-time feed through Storm and a batch input into Hadoop, and then you're writing big jobs that get kicked off by Uzi that collects all this data and then runs some sort of analytics using UDFs and writes it into Hive, which is presented through Tableau, and it better be ready first thing Monday morning when the CFO is clicking on it. Okay? You never had this problem in Oracle. Okay? You had Informatica and you had Oracle, and you were done.
Well, the job worked.
Well, you had to debug it, of course. But, I mean, this level of complexity just didn't exist. Okay? And you know, there's just all kinds of tools and processes in every step of the way. Okay? That is why this is such a hard problem, right? And you know, looking at data as an asset, which really means really think how your data is going to be used and when it's going to be used, and make sure it's ready at that time, and make sure that you can set up a scheduling and your workflow so that it's able to move through the various processes, and it's a very complex landscape on time and be ready for consumption. That's very, very important in data pipeline. So this is still sort of an emerging field. I've started actually seeing more and more job roles that specifically call out data pipeline engineer. So when I started doing a lot of consulting, I get called in to do a lot of analytics and data science. And trust me, about 50 to 60% of my time was actually spent doing this. Right? I had to do this, get the data ready before I could do any kind of analysis. And people would ask me, oh, I thought you could just throw the data and run Apache Mahout and be done with it. I'm like, no. You have no idea. This is not as easy as you think it is. So over time, I had to keep explaining to various project managers and managers, etc. Like, this is the complexity. This is all the things you got to worry about, right? Now I think there's much better appreciation of this role. And for those of you who are really looking to get into it, I think it's a very rewarding and I would say very opportune way to kind of break into the big data career space. All right, so I'm gonna actually talk a little bit on the career side, what tools and things. Unfortunately, I wish I could just tell you learn this and that and then you're done. Okay. Look at the bright side. You have plenty of job security. But these are all the different languages that are very common. Java tends to be sort of the first citizen in the big data world. Python, extremely useful. Scala is sort of this newcomer, and I think it's getting considerable traction. And a lot of the newer tools are actually written in Scala, like Kafka, etc. And it's actually a pretty cool language. So I actually predict that Scala would definitely see a lot more of Scala, and especially in the data pipeline side. And Pig is sometimes called the duct tape of the big data world. It just glues everything together, and it's the workhorse. So even if you don't choose to use Pig, it's a very important thing to know. You've got to know Flume, Scoop, Storm, which has become extremely popular, and Hive and HBase. Right? These are sort of the standard components along just regular MapReduce. Right? Now you might say, hey, this is just way too much for me. Okay, I'm a programmer. I want a very simple, easy approach. Well, despair not. Okay, so others have decided, okay, we're going to make your life as a programmer easy. So they built programming APIs. And the most popular one that I would recommend learning is cascading, which is actually written in Java, but people have put Java wrappers around it. I mean, in other languages, JVM languages like Scala and Clojure. So if you're a Java programmer, you could just use Java with cascading. But if you're a Scala programmer, you can use Scalding, which is Scala around cascading. Or if you're Clojure, you could use Cascalog. And they've started doing things with Python, etc. If you're very strong in programming, and you don't mind whipping out your IDE and getting to code, I would recommend this over the previous slide. This is a lot easier. It's a lot more testable, and I think the future is heading in this direction. I see more and more of the projects that I'm working with. People are starting to use cascading or Scooby or any of these data flow frameworks, much more than what people used to whip out with Pig and Datafoo and whatnot, right? So this is sort of the other thing. So how do you really go about doing this if you're going to do this for a career, right? So my recommendation would be learn a good framework like cascading. Learn about all of the different commercial or open source tools, and there isn't, unfortunately, a lot of open source tools to solve those problems that we spoke about before. But definitely learn a lot of the commercial tools because you might be integrating with those. And then cascading itself has quite a few extensions, and these are some of the really good extensions to learn. And this is actually a lot easier way to deal with Hadoop than doing core MapReduce in Java. Okay, so if you're new to Hadoop, I would highly recommend you look at cascading, unless you really want to go and whip out and start writing a lot of Java code and doing core MapReduce. You can. I mean, there's nothing wrong with that, but that's almost like one lower level of access directly, and they make it much easier to work with Hadoop. And as a data pipeline engineer, you've got all kinds of other problems to worry about rather than sitting and debugging your MapReduce program. So definitely look at cascading and definitely look at driven, which is pretty awesome extension to cascading.
What does Driven do on top of cascading?
It's a data workflow thing that makes it really easy to do scheduling, etc. with cascading. And cascading makes it easy to write extensions. So somebody else came and wrote. It provides more fine-grained calendaring support, better testability, better visibility, and I think it actually comes with a UI as well.
Oh, okay.
So you can track your workflow. Yeah, none of the previous tools actually have UI. Okay, it's all command line. Okay, so if you want a UI, you're better off using something like this, or buying a commercial tool like Pentaho or something like that, or Talent. Okay. So again, if you choose the programming framework approach, you can whip out code, and that will help you solve some of those problems that we saw before, right? If you want to start writing your own data lineage, data provenance, etc., you can very easily write extensions in cascading to solve that. And if you do, please contribute it to open source, and we will love you. And this is a real flexible approach. So one of the key aspects of this talk was how do you make it flexible? I find the commercial solutions a little too inflexible. I find them like, okay, you got to do it their way. A lot of them are just doing code gen. They're just generating code for you. And then you've got to go and so they generate a stub and you've got to go fill in, and it's pretty yucky, actually. I like this approach. It's a lot cleaner. It's much more intuitive as a programmer, especially if you got pretty strong programming skills. It's much more testable. It's much more modularized. And they've got nice plugins to deal with all of the different beasts in the big data environment. So you can deal with Kafka, you can deal with Storm, you can deal with Spark, you can deal with Samza, which is like, again, another stream processing framework outsourced by LinkedIn. So a lot of these tools, it's got bindings for a lot of these tools that makes you easier to work with. So very flexible approach, and this is what I would recommend. Okay. And the other topic was, how do you scale this, right? Now here's the thing. It's your pipeline is only as fast as the slowest link, and often when you're building a data pipeline, you're going to end up with Flume, Kafka, maybe Storm, Hadoop, HBase probably, Hive. So some of these components you don't really have to worry about. It just scales. I mean, you unless you do something really bad and completely mess up your Hadoop installation, for the most part it scales reasonably well. There's still a lot of fine tuning you got to do. There's still a lot of fine tuning you got to do with HBase and Hive, etc. But there is no core scalability problem per se, right? If you can go look up best practices or read a book on Hadoop operations, it'll teach you how to scale these things. And Flume scales. I've seen it scale to ridiculously large volumes. Kafka scales. It's proven. It powers LinkedIn's data pipeline. So these are all mature production systems that are proven to scale. Scoop, which shovels data in and out of relational databases in Hadoop. Okay, and if you're using Scoop for large data ingest, I feel sorry for you. It is actually no. I take that back. It's actually not a bad tool. The problem with Scoop is, you've got relational databases and you've got Hadoop, and Hadoop is a monster. Okay, if you turn it loose, it will just suck all the compute and network bandwidth out. Now, if you take this, let's say you have a 60-node Hadoop cluster in production, and put it against, a 2-node Oracle rack cluster, and you're doing a pull, it will melt that machine down. Okay, so don't do that. Okay, go easy on the Oracle ingest. So again, this is one of those things which is inherently slow. You're dealing with a slow system, and you're matching a very fast, powerful system against a slow system. Throttle it, and do it incrementally. Don't just turn it on in full speed. Okay, and try to parallelize so that you get more and more speed, but always be aware that don't melt your actual relational database down. Okay, that would be a very bad thing. So be very aware that when you're building data pipelines, although Hadoop and Kafka and Flume and all of these things are built to scale, the things that you are talking to were not built to scale. At least they were not built to scale to this level. So be very mindful of that and throttle it, okay? And do it incrementally, yes.
But most of the massively parallel processing database implementations have parallel loads. You should be able to match that impedance, don't you think?
Yeah, so the question was, MPP systems, have parallel loads. Now, yeah, this is not really a problem when you're dealing with a Netezza or or Teradata or any of those systems. So those can easily handle the load. Actually, I mean, in some cases, they will outperform Hadoop. This problem comes when you're dealing with legacy, I shouldn't say legacy, but relational databases like Oracle or MySQL. Just because the query volume that Hadoop can turn on those databases will just melt those databases down. They weren't designed to handle this, right? So I would say when you're dealing with relational databases especially, do throttle it, and baby steps is a very, very good thing to do with Scoop. So if you're building a data pipeline and anywhere in that data pipeline there is Scoop, I would say use one performance benchmark for every other piece of your system, and then use something else for Scoop. You got to treat it very special, okay? It's almost like this. You kind of have to treat it with kid gloves, because if you try to scale that to the rest of your big data system, yeah, that's a problem you'll never solve. Okay. So yes.
I mean, talking about melting things down, what are you using for monitoring stats, graphite, different things?
So question is what is used for monitoring? The most common thing is Ganglia, which is sort of this federated monitoring system that Hadoop comes with. I've seen people do Nagios. I've seen people do Zabbix and graphite. It depends on whatever the established standard in that company is. For the most part, people stick with Ganglia actually, and it works just fine. Ganglia, yes. Now, monitoring ETL jobs, or monitoring a data workflow, that's a different topic altogether. There are no tools for that, unless you use something like cascading and something like driven. That gives you a tool to actually monitor your workflow. If you're rolling out your own using Pig, etc., you're kind of on your own. You can instrument it and you can plug it in with whatever monitoring system you're using. I mean, that's just way, way, way more work. Which is why I really recommend the programming approach. So that's one of the benefits, that you actually get monitoring baked in right there. Okay, so the second one is Zookeeper. Somebody asked me a question about Zookeeper. Zookeeper is sort of, you can think of it as a distributed coordination mechanism that's at the heart of Hadoop. You cannot run Hadoop without Zookeeper. A lot of the other systems like Kafka, Storm, etc., also depend on Zookeeper. And if you're running one Zookeeper quorum for all of these systems, you're doing a very bad thing. Try to separate your Zookeeper quorums for your different systems, and you can scale them separately, okay? And definitely do not mix anything else with your core Hadoop Zookeeper. So if you're running Kafka, run a separate Zookeeper quorum just for Kafka. If you're running Storm, run a separate Zookeeper quorum. Don't mix that with your Hadoop Zookeeper, okay? And Zookeeper is actually pretty fast, but not super duper fast. It's not at the same level of speed as some of the other systems. So you've got to be aware of that. And especially if you're using things like Kafka, which uses Zookeeper heavily, or even Storm, understand that that could be a scaling problem, and you need to factor that in. Okay. Storm also relies on something called 0MQ, which is a message queue underneath for transport, and they are changing this actually. So the next version of Storm, I believe, is going to have better performance on the message queue side. So 0MQ is actually amazingly fast. It's amazingly fast for small events. And Storm came out of Twitter, and obviously they were analyzing tweets. What if your message happens to be large? You will see
small, large. I know it's relative, but
several hundred kilobytes, as opposed to a few kilobytes for text.
Okay.
Right. So let's say you have binary dumps of data or something like that, right? And that actually happens when you're trying to do fault prediction or something like that, and you're doing diagnostics in Storm. When that message gets to be that large, several hundred kilobytes, 0MQ is not very efficient in transporting that. So it's not the fault of Storm, it's the underlying transport that's slow. So what do? One approach is you can compress it. If it's text data, you'll get some pretty good compression. So, but I would not recommend shoveling around large events just natively. Okay, do something smart to reduce the size of the events. And another thing is you could partition the message itself and try to put it into smaller bits, right? But understand what these systems are using underneath, and those are often the scaling problems. Right? Yes, question.
Is there an underlying case safety mechanism that allows for high availability for all these key value stores?
So the question is around high availability for all these key value stores. High availability often tends to be an afterthought in the big data world. Now, having said that, Kafka and Storm are aggressively building high availability. In fact, the latest version of Kafka has some HA features.
Is it just plain replication, or is it just a case safety mechanism?
It's mostly replication based. And a lot of times they use Zookeeper for some of the state management. Yeah, and Storm, the next version of Storm that will run on Yarn is guaranteed to be highly available because it uses Yarn's high availability features.
The Zookeeper also takes into account, like, if the master itself fails, does it recover, like, even if the master fails?
So questions around Zookeeper's high availability. Zookeeper is it runs as a quorum-based system. So if you run in a multi-master mode, it does some sort of pure election to manage it.
Consistent hashing, right?
Yeah, leader election is sort of the approach used. So some of the good practices, benchmark for your end-to-end throughput. Okay, don't just go benchmark individual components in your system. So don't just run a benchmark on Hadoop, run a benchmark on Kafka, run a benchmark on Storm. Benchmark from all the way from ingest all the way to consumption of your data pipeline. Okay, and that gives you a pretty good idea of which ones to scale, and be aware of which ones are slow. And those are the ones you kind of have to give special treatment to. Okay. Second, and I see a lot of people do this, and this is again a very subjective statement. I would say benchmark your fast systems first. Okay, that's sort of like your low-hanging fruit, and fine-tune your HBase, fine-tune your Hadoop, fine-tune Storm and Kafka, because it's very well known how to scale these systems, and these are highly scalable systems. So go read up on it and do a good job and fine-tune and benchmark and do a better job on your fast systems. Then come to the slow systems, because the slower systems are inherently harder to scale. So you would be spending a lot more time trying to improve the performance of Scoop, etc. So I would say tackle that next. For the most part, if you've got your core systems fine-tuned and performing well, I think you've solved a good portion of the problem. And the other ones, you just have to deal with it. I mean, it's not that easy scaling anything that talks to a legacy system, And the last kind of piece of advice I would say is run the slower parts in batch. Okay, resist the urge to go real time on everything. Okay, if you're doing real-time analytics on your log events, that's one thing. There is no need to replay all of your database transactions through Storm and run real. I mean, unless you're doing something so unique that it needs that, right? I've seen people do this, and almost always a bad idea. Okay, so if you're doing imports of data from, say, mainframes or relational databases, try to do it in batch. There's no reason to kind of, just because you have a Storm cluster and just because you have Kafka, don't just run everything through that, right? Batch is good, and it's built for use cases like this, right? And try to aggregate data as much as you can, right? You don't need that fine-grained data unless you're going to do something with it, in which case bring it in. But if all you're doing is counting values for the last day of sales, then aggregate at the day level and bring that data in. Okay. And so here's my prediction. I think this is actually going to be one of the most challenging areas of big data engineering, right? So if I really think of big data, I see 3 parts. I see the infrastructure side, which is what all the major Hadoop distro vendors and the people building Kafka and Storm and all these things, right? They're all building the infrastructure. Then I see data science and analytics, which is all the applications that can come out of big data, right? But then there's this huge piece in the middle, which for lack of a better term, people are calling it data engineering, although I like the term pipeline engineering better. And I think this is actually going to be one of the most hottest growth areas in the big data career space. We've seen why it's a complex problem. We've seen why it's hard, and all of the different skills and tools and techniques that you need to learn. So I really see that there's going to be a skyrocketing demand in this area. Of course, there's going to be huge demand for data scientists. Of course, there's going to be huge demand for admins who can set up clusters. But this is the unaddressed area where, as programmers, you can get in there and make a real difference. So this is sort of my prediction is this is going to be sort of one of those sunrise career areas in big data. And a lot of innovation, and hopefully some of you will contribute to this and make us all happy with open source, okay? And welcome, a great place to start. Thank you. Question? Yes.
In addition to those very good topics that you mentioned, there's another major area having to do with big data, which is just the semantics and the labeling of the information as it moves around the system. So wouldn't you consider that something that needs to flow in the pipeline and needs to be addressed from the point of view of being something that is a big issue with big data?
Absolutely. So the question is, in addition to data science and infrastructure, what do you deal with the semantics of data and the labeling of data as it's flowing through? I would really consider that part of data engineering. Data engineering would involve security. It would involve things like data lineage and provenance, data governance. I briefly touched upon data governance, data lifecycle management. So some of the things you're talking about, I would kind of put it somewhere in the data governance bucket. And a lot of exciting things going on in that space. I actually predict that there's going to be startups or companies addressing very, very specific points for all of these issues and solving them effectively. And I really see no other way, because startups that are starved for cash, they might go in and do some open source and build some things on their own. A bank or a large healthcare company is not going to do that. Their core competence does not lie in big data engineering. They're going to go look for a company that sells a product, buy that, install it, and be done with it. So I definitely, those areas, data governance especially, it's very, very hot. I believe in this Strata conference, there was like 4 or 5 companies working on that. So that tells you how hard it is.
I mean, it's one thing if you're doing big data for the purpose of doing, say, data mining, predictive analytics. You're looking at lots of small things. You're trying to see patterns in, Bayesian analysis, whatever. But if you're also trying to have a larger ontology that has a model that you're trying to use, basically RDF or Sparkle or tools that are designed for inference, that's coming from the top down, and that would affect your entire view of all of your data.
Yes, yeah. So the question is, how do you put in things such as ontology and semantics and classification on data sets to make it easier for data scientists? It's very important. There is actually a company called Revelytics. And in fact, even Revolution Analytics is kind of touching on this. But Revelytics has a couple of products called Loom that kind of do exactly that. So before your data scientists can get their hands on data and start to do something interesting with the data, we saw the amount of effort that's involved in getting the data ready. So what they do is provide a platform that makes it really easy. In fact, they claim that you don't really need to hire a data engineer if you use their product. I tend to disagree. But they've actually addressed data lineage, data provenance. They're starting to address data governance, data lifecycle management, ontology, metadata extraction, metadata registry, a whole bunch of things.
I believe it's also bitemporal.
I'm sorry?
Yeah, I believe it's also bitemporal. You keep track of the time periods, but the data is active in various states.
Yeah, there is. I don't know if it actually tracks the data lifecycle as much, because there's an open source project called Apache Falcon, which is part of Hadoop, which is starting to address that. But they're touching upon a lot of the other subjects.
So the last question I'll ask is the one I
Please,
came
go
in
ahead.
with, which I thought you were going to address, was the issue of scalability in Hadoop. Hadoop has traditionally been a process that starts a job, or runs a job, and finishes the job. And if you want to do it again, you have to reinitiate that process, and that startup and stop down time of the processing is in fact a bottleneck in Hadoop of sorts. So I was curious about the nature of keeping the pipes open, and you're always filling, you're consuming pipes in a continuous fashion where you never close the jobs. I thought that was where you're actually going to go with your scalability.
Yeah, so I had so many. So the question was on the scalability aspect of Hadoop, and I think what you're referring to is continuously running MapReduce jobs. This was more around the data pipelining aspect, scaling data pipelines, and not necessarily scaling Hadoop. There are frameworks to address that. Spark, for example, right, which is an open source project from Berkeley, it has this notion of mini batch. And you can keep kicking off mini batches, and that precisely addresses that problem where there's a long lag in starting and stopping traditional Java MapReduce programs. So instead, load the data in memory and use mini batch. And Spark is being widely used. Insanely complex problems. I mean, people are doing things like genomics in real time using Spark, and it blows my mind what they're doing.
I thought we talked about Spark.
Spark, if I were to talk about Spark, it's probably a separate topic in and of itself, and frankly, I'm not as qualified to talk about it. Maybe ACM can reach out to the people who actually write Spark. I think they will do a much better job of it.
I thought the points you made were very good.
Thank you. Appreciate it. Yes, please.
Many relational models these days, they're relaxing the consistency model, like maintaining the weak consistency model with their ACID properties to make them more scalable these days, just to compete with many of the key value stores that are available in the market. So how do you rate the two? Like once relational model gets to a point when it scales to the same extent as all these key value stores, be it Hadoop, be it any other key value store, how do you rate the two, like in terms of?
Okay. So the question is, a lot of the relational databases are playing around with their consistency levels and giving options so that they can compete with some of these NoSQL systems. So I would actually kind of disagree with you on that. What I've seen is there's traditional relational databases. Then there was this whole host of NoSQL systems with eventual consistency and all that fancy stuff. And then there's this new SQL systems, right? Like, I forget the name. There's like a whole bunch of them. Some of the Postgres engines.
Many of them are in memory with the Many of them are in memory with weak consistency models.
Yeah. So the new SQL systems are trying to do that, where they're providing SQL, right, so that you know a familiar query language, but providing more of the eventual consistency type of approach that NoSQL does. So I'll answer your question saying, first of all,
Sorry, can I add one more thing? And they also act as a cache to the main.
Yeah, so they have caching features. So it's sort of they're competing with. Yeah, so they're competing with the NoSQL systems, right? I actually like to dispel this myth that relational databases don't scale. They scale just fine, and they're very, very mature technologies that have been around for a long time. It's perfect use case for structured data, and I mean, Facebook runs on MySQL. There's some very, very large databases running on Oracle. So, and very few people know this. The relational database vendors are not just sitting quietly letting all these guys go ahead, right? Oracle now has in-database MapReduce. Okay, so they are competing very powerfully, and there's a lot of innovation going on in relational databases. The new SQL systems are trying to combine the best of NoSQL with relational databases. We'll see where that goes. I mean, so far, NoSQL I think is very good for semi-structured data, time series data, things like that, right? Where you kind of have loose schemas. They give up a lot to accomplish that kind of performance. So you really have to ask yourself, Mongo does this soft write. Okay, it writes to memory and somehow tells you, okay, I acknowledge you're right. Which is fine if you're building a logging system. If you're building a system where you're doing check-ins on Foursquare or a like on Facebook, out of 1 million likes, you miss 10,000. Okay, it's not the end of the world. I wouldn't build a banking system like that, right? So that debate's sort of a religious debate, I would say, still in terms of scaling. But
no, I'm talking more in terms of performance numbers.
Again, that's relative, right? It depends on what kind of data and what use case you're talking about. If you're dealing with structured data, I would argue that relational databases would still outperform many of the NoSQL databases, right? I mean, outperform by a mile, not even by a little bit, right?
The real question is RAM residence or not. If it's memory resident,
yeah,
that's where the speed is, and you can have complete consistency. It's that you have eventual persistence.
So
you have complete consistency in the system, and it's failover redundant, so it's high available.
Yeah. To that gentleman's point, this idea that NoSQL have kind of put in everybody's head that, hey, loosen up your consistency level and voila, you get this massive performance boost. That's nonsense. I mean, anybody with basic database systems theory can easily disprove that, right? I mean, they're doing that obviously as a marketing ploy. There is a reason why strong consistency exists. There is a reason why you need ACID. So if you need ACID, trust me, Oracle will outperform on ACID way over something like Cassandra. Okay? But if you don't need it, and you don't need it at all times, and you need eventual consistency is good enough, and you want cross data center replication, and you're dealing primarily with sensor data, log data, where you're okay with losing some data, yeah, Cassandra will probably do a better job. And guess what? Oracle has a NoSQL database now as well. So I think the jury's out on that question because I don't think the relational database vendors are going to just sit back and let these guys come and steal all the thunder. So I think they're fighting back pretty hard. So, any other questions? Well, thank you very much. I hope you found it useful. Thank you.